All right, y'all. We got a lot of terminal to talk about, and one day, I guess, to cover it all. So, you've been running a lot of commands, and you may or may not have fully understood what's going on there. So, this entire week is really just going to be about getting down to the low level nitty gritty of these commands, kind of just to show you how they work, give you an example of them all, and yeah, just get you up to speed, essentially. So, a lot of times you're going to run into situations where I guess you need to change a file, look at a file, get to a spot in the file system or something like that. And so we'll cover the commands to do all of that. But one thing that you're going to do, one thing that you're going to find is that you're going to be typing path names over and over and over and over and over and over again. Whether you're in one spot and you're just trying to find a file in another spot, or you're in the directory with the file, you'll need to be typing something to reference that file. So there are a couple of ways to get the job done. The first is a relative path name. So this is basically from where I'm at, where do I need to go to get there? So let's take, for example, let's look into these first two commands, cd and ls. Ls is the one that we're going to find, or that we're going to use the most here in this situation. So ls is list. It will list things inside of a directory. That's its entire job. So if you do it by itself, you can see there are some files, some in red, some in blue, some in white. So in Ubuntu, these colors are, well, the colors are fairly standard across a lot of distributions. So you're going to see these same colors no matter where you are. But the red means some kind of archive of some sort, right? I mean, if you look at the file that we played with to install, this is Discord and it's .gz. So we'll talk about gz here in a little bit in this lesson. And then you got .zip, which you're probably more familiar with. The blue are directories. So desktop, documents, downloads, music, pictures, public, templates, videos. And then the white are just regular files. So these are the types of things that you're going to run into. So keep those in mind. You don't have to memorize these colors or anything like that. Honestly, when you see them, they'll mostly become pretty obvious what they are. But if for some reason you run into a situation where you're like, I don't know why it's colored this way or something like that, ask. Just let me know. You'll also see green. If a file is executable, you'll see it in green. Those are the ones that you're going to run into the most. We'll look at the devices directory and we'll see all kinds of cool colors in there as well. So anyway, so ls shows us stuff inside of a directory. So let's say we want to look into a directory that I'm not in. So remember at the very first, I think it's like in the first or second week, we talk about this pwd command. And pwd shows us where we are. So we are in the Leo directory, which lives in the home directory. And the home directory is at the very top of the file system. So I'll show you some examples of that here in just a minute. So let's say when we did our ls, we noticed there's a downloads directory up there, and that tends to be where most of your downloads go, especially if you're downloading from a web browser or something like that. Let's say that we want to go into it. So to do that, we'll do the cd directory, or the cd command, which is change directory. Now notice though, and this is going to be something that happens with Linux forever, notice the capital D in downloads. Let me just show you what happens if I ignore it. So cd downloads. Yep. cd downloads. No such file or directory. Has no idea what I'm talking about. There is no such directory called downloads that's spelled like that. If you want to get into the downloads folder, you have to type it exactly the way that it appears, and that is with a capital D. So to get in there, now let's do an ls to see what's in here. Nothing. Nothing at all. All right. So now we're in downloads. Well, how do we get out of downloads? I don't want to be in downloads anymore. There's nothing in here. There's nothing for me to do. So to get out of downloads, there's a symbolic link that you want to follow. So cd ... This is something that was come up with in the 70s or the 80s. And I mean, honestly, I think the translation has been lost over time. But there are a couple of things that you'll need to know about these dots. The first one is one dot, a single dot, means here, right where you are. So if you want to, instead of having to type in the entire directory of where you are, you could just type a dot, and that will represent here. And it doesn't matter where you are in the file system. You could be in any directory whatsoever. It does not matter at all. The dot means here. The ... means the directory above here. So if you notice, when I did downloads, cd ... that took me up a directory. When I did cd downloads above here, I went, you can consider that down a directory or inside of downloads. So the cd ... moves you back one. Back one or up one, however you think of, however you visualize the file system. I visualize it in a way where the root of the directory, or the root of the file system, which is just that /, is the very tip top of the tree. And then everything kind of splays out from it from there. So when I say go up a directory, that's how I'm thinking about it. So I'm at the root of the directory, or the root of the file system. I go to home, then I go to Leo, then I go to downloads, and then when I want to go back up one, that cd ... I'm going up a directory back to the Leo directory. So anyway, so if you hear me say weird things like go up one or something like that, that's what I mean. Yeah, all the directories go downward as I go into them, as I get deeper into the file system. I know some folks like to think about it the opposite way. As they're going deeper and deeper, they go up. But anyway, so yeah, as I talk about it, that's it. I'm moving down as I'm getting deeper, moving up as I'm getting closer to the root of the file system. Okay, so there's typically there are a couple of different options that you want to know with ls. And typically it's these right here. So L and A. So LSL gives you this long listing. It's pretty fantastic. It allows you to see who owns the file, which is and we'll talk about permissions more. I don't want to go too deep into this. This is kind of off topic, but who owns the file, who group owns the file, how big that stuff is, the last day that it was touched or messed with, and you can gather a lot of information using long listing. When you add the A option, you'll notice there's way more stuff in here. And the common factor, what doesn't show up without the A and what shows up with the A, are files and directories that start with the dot. So if you ever see a file or a directory that starts with a dot, know it's a hidden file. So just like in Windows, you can right-click on a file, go to Properties, and check the hidden box, and it'll go gray, or kind of like ghost out a little bit. And if you don't have the option checked to see them, you won't see them. That's pretty much what a dot does in Linux. So to finish up this thought, there are relative path names, and that's what we did with the downloads folder. CD downloads, right? And there's nothing in there, so I can't really go further in, and I can go up. So let's say I went to the root of the file system. And we're looking at all of these. And I want to go into the temp directory, this TMP right here-ish. Let's say I want to go in there. I can just type in TMP. And there's a bunch of other stuff inside of there. So let's get out of there. Let's say I want to go into USR right here. And then I know there's a directory inside of USR called bin. So I can go in there. And I think Firefox lives in here. But there's tons of stuff, right? Here's green. what I was talking about before. Green shows up. These are executable files. That light blue is a link. So anyway, here's the thing. Right now I'm deep into the file system. I'm in a place where if I want to get back to my downloads folder, I'm gonna have to do some work. So here's the difference. So relative file path, I was able to just say, hey, I'm in a place that contains a directory called USR. Let me just go into the USR folder, and I can just do cd USR. Well, now I'm not in a place where I can just go into my downloads folder again, right? If I can try. I can do cd downloads just like I did before, and that's not going to work. There's no such file or directory. There's no directory in here called downloads. So how do I get back? There are a couple of ways, but I'm going to show you the absolute path name. That's the word I was looking for. Absolute path name. So from anywhere in the entire file system, you can type this command and get to that place, whatever place that may be. So absolute path names always start with the root of the file system. So in my case, the root of the file system, well, I mean, in every case, the root of the file system is that. But in my case, if I want to get back to my home directory, it's going to be home/Leo/downloads. So this will take me all the way there. So let's do that. This is an absolute path name. And it takes me there. Let's do pwd. And there it is, right? Absolute path names are quite literally the entire instruction set. It's a map. You go here, then you go here, then you go here, then you go here, then you go here. Then, I'll be where I want to be. As opposed to, just moving one directory at a time. cd this, and then cd that to get into directories. So we can do that, right? Let's do the absolute path name of the user directory, which was just root of the file system, and then the USR directory. So this is absolute. Even though it's short, it's absolute because it has that / at the very beginning. And then let's go into bin. And now we're back where we were using, first step was an absolute file path. Then the second step was a relative file path. There's a bin directory in USR. So if we look at it, it basically took the USR and slapped bin on the back of it. That's essentially what's going on there. So that is pretty essential to understand the difference between the two. You can mix and match, but if you want to get somewhere, absolute path name will always get you there. Relative path name will tend to take a little thinking if you're not exactly sure where you are or something like that. So to kind of sidestep all of that, it might require more typing, but absolute path names are going to be absolute, really. I mean, it'll definitely get you there. Relatives, you got to think about where you are in the file system. Okay, so inside of here, let's just go down this list and talk about all of these commands. And there's a lot of them, so this is going to take a little bit. I'm going to try to go as fast as I can so we can get it crunched into a really quick video. And by quick, I mean, average for us here lately. So, all right. One command that we might end up using, actually that we will end up using, is zip. So let's do the file command. And we are in the directory that contains zip. If you look right here, I did an ls of user bin, USR bin. That's another thing, by the way. It is technically USR. It stands for Unix System Resources, not user, as in your user files don't go in here. It doesn't stand for user, but I do pronounce it that way because, I mean, really, it's user. So just know that your user files don't go in there. These are files. These are usually just executable files, things like commands that you want to use. So anyway, zip right here. So let's do that. Let's do file zip. And once you start looking at it, it becomes a little more obvious what it might be. So it tells you zip a 64-bit shared object. The 64-bit version, and I know it's kind of hard. I can't really hover over it with my mouse. Oh, actually, yeah, I can. Here we go. So, shared object, 64-bit, version 1. It's dynamically linked. Anyway, long story short, what this is about is showing you what type of file zip is. So if you want to know, let's see, let's go back to my home directory. Absolute path there, because it has that / at the beginning. And let's look in here again. So let's look at that Discord file. So let's file Discord. And you can see tar.gz. It's a gzip compressed data file. Let's do another one. How about file, this other big thing that we'll use here in a minute is zip archive data. And it actually gives you some information. You need at least zip version 2 to extract it. Now let's look at file nohup.out. This is one that we did last time. And, I mean, it's a simple file. Unicode text. It's just a text file. So let's check out this service. Should be the same thing. ASCII text. Just a text file. And you can do it with directories as well. But, I mean, do you need to? It's just directory. So that's the deal. So file will tell you information about a file, whatever that file may be. And everything on in Linux is a file, so you can run this command on any file that you come across to learn a little bit more about it. So while LSL, as I did up here, will show you some basic information about it, like permissions and file size, and last time it was used, file will show you more information about that individual file, whatever that may be. So, touch. Now, we were talking about, or I just mentioned the last time it was accessed. So let's look at this nohup.out. Last time it was touched was on January 27th. Let's update that. Touch nohup.out. It doesn't really do anything. There's no output. But let's look again at a long listing. And now notice, on this line, it no longer says January 27th. It says February 3rd. So touch is a simple command that does one thing really well and another thing by accident. So the one thing it does really well is update the last time a file was touched. So if you touch a file, it will update the last time that it was accessed right here, or that it was changed right here. This is useful in a situation where you need to verify that a log has been read. Well, just reading the log file, using less and then typing out the log file path name, it doesn't update anything as far as time goes. So how do you know? How do you know that you actually read the log? So you'll do the less command just to look at that file and go up and down and find what you need and say, oh, cool, this whole log file is fine. I don't need to worry too much about it. After you're done using the less command, you'll want to touch that file. That way you remind you, or if you're in a team, you remind your entire team the last time that file was accessed. So touch is pretty useful in that way. It's also useful if you just want to create a file. You don't want to put anything in that file, but you just want to create it. So let's see. Let's call the file feel. Touch feel. Let's look at it, and there it is. So touch is not meant for this, by the way. There are many better ways to actually create a file. Touch will just create an empty file, which there may certainly be cases where you might want to create an empty file, especially where you want command output to go somewhere or something like that, and the command just doesn't like it if the file doesn't exist. You can just magic up the file and have it be there when the command is run. But most of the time you use some other command to create the file. Like, if we do nano test file, this will create the test file as well. So we can, put a bunch of junk in it, save it, and get out of here. And then notice, test file, it's down there. So you don't really need to create files with touch, but in the situation where I need that file, I need it now, you can just touch it, and then you can decide what to do with it later or something like that, as a placeholder maybe. Anyway, CP, short for copy. So let's copy a file or two. So we have, let's look at that some HTTP server.service file that we have right there. Let's say that we want to create another service file that we haven't created before, but we want the template. So what you can do is CP sum and tab. Don't forget, tab will finish out if there's no ambiguity in what that file name is. Right? If you look at that list, there's no other file or directory that starts with SO. As a matter of fact, S would do just fine. We can do anyway. So you can use tab to finish that off. Now we want to create, or we want to basically create a file name that we want to copy this stuff to. So let's say template.service, and then hit enter. All right. So the way that this works is basically copy this to that. That's how that works. So let's do LSL. Now we see some HTTP server.service still there. Doesn't change at all. You don't want it to change. We're copying it. And now we have a new file, template.service. And if we look at them both, let's do less some HTTP server. Let's look at that. It's got those few lines in it. And then less template.server or .service. And it's the same exact thing. So now we can go in with Nano, our text editor, to template.service. And now we can edit it. So just for fun, this is a template. All right. Anyhow, that's the deal with copy. You can do some really interesting things like mix relative and absolute path names. Let's say we want to put a copy of this in the temp directory or something like that. Let's copy template.service. But we want to keep the same name. We actually just want a true one-to-one copy. Let's do that. So absolute path name here though, because we are not in the temp directory, we have to specify. All right, start at the top, kind of make your way down, TMP, and inside of here, I want template.service. So let's copy that in there. Now here's a cool thing. You can mix and match. You can add a directory to the ls command to list that directory's contents without being in it. That is useful as well if you don't want to have to go all the way there and then come all the way back. And there it is. There's your template.service. So now it's in there as well. All right. Move works the same way. So let's say we want to move the feel file to temp as well. So we can do this one of two ways. We can move feel to temp. Let's do that. Let's just do it. And we LSL TMP. And there it is. Let's move it back. I want to do something else with it. But I'm not in the temp directory, so I'm going to have to use that absolute path, TMP, feel, and I want to move it. Remember what I said about the single dot? Here. And there's the feel file again. So it's back. Let's look in TMP. There's no magic happening. It really is not there anymore. I moved it from one place to temp, and then from temp back. All right. So one of the cool things that you can do, let's keep it all in this directory for now. let's move feel to touch. So what this is going to do is quite literally just rename it. Because I didn't tell it to move any particular other directory, it assumes you want to move it from here to here. But since we give it a an output name, so right, mv, which is move, feel, which is this file, touch, that file. So move this to that right there. So no more feel. It's no longer up here. It's down here called touch. Now let's get this out of here. Let's put it back in temp. But I want to rename it back to feel. So remember before, when I moved it, I did mv, it was feel at that time, but this is still the same example basically. Mv touch to the temp directory, that will move it, and it will not change its name or anything like that. But let's say I want to do both. Let's say I want to move it and change its name. You can do it like that. Move touch to the directory tmp and name it feel. Now let's lsl tmp and check if that worked. Sure enough, feel. Every time I do these things, I swear, I look at these words so many times, and I'm pretty sure that's how you spell feel, but I can't be sure at this point. All right. So DD. Actually, you know what? This one does need to be a little further down. So we'll come back up to DD, and I'll move it around in the notes here in just a minute. So let's look at makedir for now. mkdir. So makedir as in directory, make directory. So that's how you make a directory. That's quite literally it. So makedir, let's say we want, I don't know, a dir, a directory. LSL, and sure enough, there it is up at the top, a dir. Now, again, careful with the uppercase letters there. If you don't type a capital D there, it ain't going to work. So to get in there, you can't just say a dir. Nope. You have to type in a D, big D, IR. Right? That works. And then to get out of there, remember, CD ... will move you back. So, I mean, notice it keeps track, by the way, your shell. Keeps track of where you are. That little tilde right there means your home folder. Doesn't matter who you are. It's just a representation of your home folder. So if you are, in the middle of nowhere, say you're in temp or something like that, you want to go back to your home folder, you can do it two ways. You can just type CD. That'll work. But you can also do CD and that tilde, and it'll take you back. Notice your directory changed from TMP to that tilde. If we do pwd, I can prove it to you. Home Leo. All right, so we made a directory, a dir. Let's remove that directory. It's got a special command for it. And let's double check, it's not there anymore. But rmdir, remove dir, is really not that useful because if there's anything in that directory, it won't work. So let's create, let's call it dir, just for fun. Let's go, actually, you know what, let's just do touch, so I can show you some more relative path naming stuff. dir / and let's say file1. And you can do multiple files, by the way. File2, file3. Let's lsl dir. There they are, file1, file2, file3. The difference there was that I spaced between each one. If you add a space and you have a command at the very beginning, that command is going to assume, all right, I'm going to do whatever I do to this thing, then this thing, then this thing, then this thing. You can do that a lot. You can do that for just about everything. Anyhow, so we have all these files. Now let's try to remove rmdir dir. Directory not empty. Ah, man. So this is where the rm command comes in. Now, keep in mind, if you're in the command line and you're removing stuff, there is no trash can. So if you remove it, it's gone. you're going to have to use some file recovery software or something like that to be able to get it back. So yeah, there's no temporary holding storage or anything like that for files that you delete. So when they're gone, they're gone. So RM, but RM requires a little bit more because, take a look at this, RM doesn't do directories by default. That's why rmdir, rmdir exists. But if rmdir doesn't work and you don't want to have to go in and meticulously, I mean, imagine if there were like 1,000 files in there or something like that. That wouldn't be great. You would have to go and delete all of those files and then come out and then delete the dir directory or something like that. So we don't want to do that. I'm done with this. I want this whole thing to go away. So you'll do recursive, which is the directory and anything inside of it. F is force. Basically, you're telling the terminal, don't ask me about it. I'm sure, I'm positive. Just get rid of all of it. And then you say dir. And that'll get rid of it. So we no longer have dir. All right, so just like the LSL, there's an option L. RM has options too, and in that case, RF. So be quadruple sure that what you're deleting when you do this is exactly what you want to delete before you hit enter, because again, no trash can, so be careful. All right, locate. Locate is a pretty fantastic command, but it pairs with update DB. Update DB updates the entire database of every single file on your entire system. It's pretty fantastic. So update DB requires sudo because it has to go into directories that you do not own and you do not have permission to. So you have to say, all right, as root, let's update the entire file system database. It doesn't take very long on smaller systems, systems that have less than 10 gigs of files on them. Yeah, it's pretty instant. Systems that have even more than that, still pretty instant because all it's really doing is enumerating all of the stuff on the system. So a lot of times it's more disk bound, speed wise. It's more disk bound than anything. So once you update the DB, you can start looking for stuff. So you could quite literally just say locate, and I want to find music. So anything that starts with a capital M, music. So obviously the one in my home folder, right? You saw that one. But there are a couple others as well. There is a, an application called GNOME Music. And there's a picture, PNG. So this is an icon of something that, I don't know, just a music icon, I guess. And you can do this with absolutely anything. You can do this with zip. It'll find everything with the with zip essentially in the name somewhere, anywhere. It does not matter. So what you might want to do with this is pair it up with other stuff, but we're not there yet. So that's the idea. So if you just want to find anything, let's just anything with the name Firefox in it, anything with the name Leo in it. Tons of that stuff. But notice here, right? User share help SR Isle Riot. Oh, I think that's a game. And then it says Napoleon. It's got Leo in there. Napoleon has Leo in it. So Locate was like, hey, it's there. It's got Leo in it. I found it. You're welcome. So you've got to be careful with that. So when you're locating stuff, you want to be as explicit as possible so you get the fewest things possible, and that will help you find stuff. There's a good example. Let's look at all of the Linux headers are basically the files that are on your system if you want to compile software together. So we talked about installing and compiling software. These are your headers. There's a lot of stuff in here. Yeah. All right, so Control-C, I'm done with that. I'm done. All right, so find, though, tends to be a little bit more explicit. So find is a way, find works similarly to locate, but it does not work off of some kind of database. You don't have to update anything before you use find. So with that update DB, one last point. If you download a file right now, your database does not include that file, so you wouldn't be able to find it. Every time, so update DB runs a couple times a day, a few times a day. So, I mean, likely if you downloaded something a few hours ago and you go try to locate it now, it might work. But if you're just not sure, just run update DB. So find does not work that way. Find literally goes through each and every directory and each and every file and looks through everything. It's a manual lookup for whatever parameters you set. So in my case, what I want to do is, as I did with locate, let's do find. So this first thing here, this first argument here is the entire file system. So it doesn't have to be this. I'll show you another example in a minute, where the name has .zip in it. All right, so here's the deal. So that asterisk right there says, I don't care what it says. It does not matter to me. If it's A or 700 A's, that asterisk says just, whatever. I don't care what it says. Just give it to me. So anything .zip, that's what I'm looking for. That's what that says. So find in the root of the file system something with the name of anything.zip. So let's do that. See, that's broken. And I've actually got in the notes too. So notice it said permission up at the top, permission denied, permission denied, permission denied. Because when I do the root of the file system, there are directories that I don't own. So it's like you don't have permission to look in those directories. So So let's do sudo in front of it. Try it again. That's more reasonable. So I ran the command here. Here are all the things, all the files on the entire system that have .zip at the end. So pretty nifty. You can do the same thing with locate. Right? Because before I did locate zip, not .zip. So anything with the word zip in it at all. Now .zip is a different story, right? Typically just the extension at the end. And they found the same thing. And locate was a little faster because it only is searching text. Find is a little bit slower because it's going into those directories. It's looking at every single file in the entire file system. So the reason that you would want to use find, one, you don't care to update the DB. You don't want to have to go through any of that, whatever. I mean, in a simple find lookup like this is pretty quick. I said I was going to do another example, which was not using the root of the file system, but instead let's look in home Leo, a directory which I do own, which means I don't need to put sudo in front of it. But let's do the same thing, right? Name asterisk dot zip. Let's look at that, and it'll only find that one file, which is in my home directory. All right, so another reason that you would want to use find is because you can tell find to do something with whatever it finds, like delete them all. So let's say that I'm tired of all the logs on my entire system and I just want to delete them all. You can do that if you want to, and I'll show you here in just a sec how to do that. But let's look at a real example. So let's look at this one. I don't have a net share directory, so I'm not going to run this on my Ubuntu machine, but we'll go through all the arguments and talk about what it means. So find, obviously, let's find stuff in the net share directory. So if you look at that file path, that would be in the root of the file system. So it would be here. Go to cd and then the / LSL. Netshare would be in this list at the root of the file system. So in that directory, find in netshare user Betty. So basically any file that is owned by Betty, that has a user of Betty, and that's talking about this column right here. This column right here is the user column. And you could do group as well, so dash group and Betty or dash group and root or something like that, but it would have to match on both of those things at that point. So it has to be user owned by Betty and then group owned by whoever you said. And then here, execute. And in this case, it's change group to accounting. So it's basically going to be Betty here, accounting here. So the group for these files and directories or whatever would be accounting. And then this is basically the ending of a script, essentially. So this is the punctuation that you would need at the end if you were running a command. So using this exec here, this execute, you need to finish it off with this. So if you wanted to say remove them all, you could do this, right? So unless you are Betty, you will need to use the sudo command in front of this. So sudo find netshare user Betty exec rm, and that will remove all of those files. Let's say, I don't know, maybe Betty has become redundant and we no longer need Betty. We're just getting rid of all of Betty's stuff. Something like that, right? You can do that. But this, like I mentioned before, will change the group ownership to accounting. So it'll find all of Betty's files, change the group ownership to accounting, and then be done. So find is way more powerful than locate. Locate is nice because if you just like, I don't know where it is, let me just locate blah, 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 bingo, it'll work. It'll find stuff. But find tends to work a little bit better when you're saying, you know, I want to locate a file, but I want to know, say, I want to find any file that Betty owns, or I want to, any file that this particular group has any ownership rights on. And then on top of that, I want to move all of those files to a different spot or something like that, right? So a group has been dissolved in the company, and you need to move all of those groups' files to a directory for backup purposes or something like that, right? That's something that you can do here. So instead of change group accounting, it would be mv space, you know, the path to the directory that you want to move all your stuff into. So find is extremely powerful. It can do a ton of stuff, and it saves you way, like a ton of work. So think about it, right? Like in Windows, how would you have to do that? It's tough, right? Having to think about where all these groups file. Like, hopefully you put them all in one spot that makes it really, really easy or whatever. But what happens if this group owns 5 or 6 directories and they're not remotely close? How would you do that in Windows? So there are PowerShell commands to do all of that stuff, but yeah, I think Bash is a little bit simpler in cases like that. But either way, it's not like you can't do it in Windows, but likely that you just never thought about it. Anyhow, which is which is a command that you will use to find stuff, find where stuff lives. So in this case, which Firefox will tell you that, yeah, Firefox lives in user bin. Now, which just looks for binaries. It looks for executable files. Where is looks for binaries and any supporting documentation. Oh, where is, not just where. There we go. So where is Firefox? Firefox is here, user bin Firefox. There are libraries in user lib Firefox. Its configuration lives in etc Firefox, and its manual lives in user share man1 Firefox.1.gz. So which is great when you want to know exactly where the executable file is. Where is great when you want to know that, as well as all of its all of the configuration files, all of the documentation, everything else. I want to know where all the things that relate to Firefox live. Show me that. So those are good stuff. All right, so linking. Symbolic links, hard links. So here's the cool thing about one of these is that symbolic links, those work exactly like your Windows shortcuts, right? You right-click on a file and you create a new shortcut, and then you have that little file with that little arrow that's kind of bending in, right? You can move that anywhere you want to, and it'll always point back to that file, whatever file it is that that you're talking about. So we can do, let me see. Oh, right. Okay. So I always forget which one comes first. So lns, let's say user bin Firefox. If I can spell Firefox, there we go. So that S, by the way, stands for symbolic. So we're creating a symbolic link. And then I want that to be in home, Leo, desktop, Firefox. Okay. Now let's LSL desktop. Oh, I'm in the wrong. Yeah, take a look at that right there. I'm in the wrong directory. I'm not in my home folder. So remember, as I said before, you could do CD tilde, as I showed you before, or you can just type CD. That'll take you to your home directory. Notice the little tilde. Now let's LSL desktop. Let's do that again. And notice Firefox, right? So I've got a file named Firefox, and it's pointing to user bin Firefox. This is important. So user bin Firefox is green. It's an executable file. The link is light blue. It is a link. And if you notice right here, there's an L. It stands for link. Another little quick thing. D stands for directory. A dash stands for any other file. So don't worry about those just yet. It just seemed apropos. We'll talk about those next week, actually. We'll talk about permissions a lot. Anyway, so a hard link. A hard link is a file that basically clones another file, but keeps them in sync. So you don't really see this in Windows. So a hard link is quite literally a way to keep two files identical that may live on two different spaces in the file system. But one of the cool things about hard links is that you can also do them over the network. So it works the same way. You would do the exact same thing, except you just wouldn't have S here. So if I did user bin Firefox and then home Leo desktop Firefox without the S, it wouldn't be one thing pointing to another, really. It would be two files that are exactly the same. So if I made changes to one, the other one would update. They are hard linked. If one changes, the other one changes. They stay in sync the entire time. So yeah, you can think of it less as a hard link and more of a sync. They sync up everything that happens. So the cool thing about this, though, is that you can have one file on your file system and another file on some network share, have them hard linked, and every time you make an update to your text file or whatever it is, the hard link, the file on the network share, gets updated as well. And that is really nice when you keep thinking about, hey, do I need to back up these files or whatever? The hard link will kind of handle that for you. All right, so the only difference, hard link, they sync up. You do not need any option. If you just want one file to point to another as a shortcut, you need the -S. This is more common, but you will see hard links when you need two files to stay in sync. All right, gzip, bzip, and tar. These are a little more complex. It kind of depends on how you're thinking about it. So let's look at some of these files here. Let's look at these text files. I want to find the biggest one. Which one's my biggest one? Yeah, it's this one. So there's nohup.out. So let's take that and let's gzip it. Really, all it's going to do is compress it. So if you haven't gotten this, the idea of what compression actually is these compression algorithms. So gzip, bzip, xzip, 7zip, zip, all of those. What they do is they look for redundant information and abbreviate it. So, 4 A's in a text file is now abbreviated A, like to the fourth or something like that. Using not necessarily mathematical notation, but that's a way that we can think about it. Because it turns it into weird binary data and all kinds of cool stuff. So, but you can think about it like that, right? Writing A to the fourth, like putting an exponent up there, is way easier than typing A, or writing A. Imagine what if you had, 700 A's. A to 700, A to the 700th, is way easier to write than A 700 times, right? That's compression. That's really what that does. At the highest level, you really don't need to understand too terribly what compression algorithms do or whatever, but just keep in mind that's the basic idea. They look for redundancies and they trim it down somehow. So let's look at how this is going to work. So notice that that number right here in this column, that is the number of bytes any particular file takes up. So 105,842 bytes. And if you think about that, that's kilobytes, right? 105 kilobytes, give or take. So what do we want to do with this? Let's make it smaller. Let's say that I'm pressed for space and I need everything to be as small as it possibly can. So we can type in gzip nohup.out. And notice it appends the GZ to the end of it. And now it's 9,000 bytes. So it went from 105,000 bytes to 9,000 bytes. And let me show you one other option that you might want to use with LS. So still long listing, but add in the H as well. That H stands for human readable. It changes those bytes into kilobytes, megabytes, gigabytes, whatever. Makes things way easier to read. So let's see, nohup.out, 9.5 kilobytes as opposed to 105 like it was before. So how do you undo that, right? Because you can't just say, oh, actually, that'll be a bad idea. You don't want to cat like gzips or binaries or anything like that. So let's use less, nohup.out.gz. Oh, actually, it does. It reads inside the gzip file. How crazy. Well, isn't that just nice? Anyhow, let's unzip it. So G unzip, or you'll hear me say it gunzip, because, I mean, it's spelled that way. So gunzip, nohup.out.gz. It undoes it. Let's do LH, so we can get that human readable number. And yeah. Oh, well, it's like that 105 blah, blah, blah number. So 104 kilobytes is how big this is, right? So, I mean, there's a lot to be compressed in there for it to, I mean, what was that? That was like that was a lot. If we went from 100 to 10-ish, give or take, that is a lot of compression. 90% compression rate. That's insane. Okay, so that's good compression. Anyway, so let's do bzip. So you can do bzip2, nohup.out. So same idea, just a different type of compression. And who won? Bzip did. It's down to 6 kilobytes, right? So don't worry too much about the compression algorithm, like what it's doing in the background. Just know that there are different types of compression for different types of uses. Obviously, bzip is the winner for plain text. However, gzip is still the more popular option, so you'll likely see gzip rather than bzip a lot of times. But, I mean, it's not for nothing. You will see some bzips out there, too. All right, so bunzip, I think it's, yeah, bunzip2, and then nohup.out. Oh. And then back to normal. Okay, so here's the thing. Sometimes you want to back up an entire directory. Well, gzip and bzip and zip and all the other ones, 7zip, they all want to do one file at a time. So what you do instead is, if you look at this Discord file, it's already done for you, and it's got a tar.gz. So tar stands for tape archive. Yep, those tapes, backup tapes, that magnetic ribbon stuff, right? Think about VHS. If you're old enough to remember what a VHS or a Betamax is, yeah, pretty much that. So, we are getting a directory or a set of files ready to go onto a tape archive. That is not really what it's used for anymore, but bundling all these files up is still extremely useful, even though we don't put it on tape anymore. So it's still called tar, it's still called tape archive, but we don't put it on tape anymore. So think of tar as bundling a bunch of things together, and then gzip or bzip or whatever goes in later on and compresses it all down as small as it'll go. So I had a direct. Oh no, you know what? I killed that directory. So I don't desktop. Do I have anything in here? Yeah, I sure do have that shortcut in there. So here's what you want to do in a situation like this. So tar create, and let's say I want to do gzip on this. So I want to create a Z stands for gzip. This file. So this F, you want that to be at the very end of whatever you're adding. And what the F is saying is, here comes a file, or here comes a directory. And you want that directory to be home, Leo, desktop. And then you want to tell it what you want it to output to. So in this case, I want it to output to home, Leo, and I want this to be desktop.tar.gz. So it doesn't move. So as gzip took that file and just zipped it up, you didn't have a leftover file or anything like that. Tar will not do that. It will not like just convert desktop to desktop.tar.gz. It's going to create another copy of it. So let's run that real quick. Oh, wait, hold on. Let's see what I did wrong. Oh. Okay. I did that backwards. So the things were right. They were just in the wrong order. So you give it the file first. So home. And as I was saying it too, I knew it sounded wrong. tar.gz. Okay. So I want to create a zip or gzip. And then the resulting file is this. Home Leo desktop.tar.gz. And I want to, what was that about? And then I want to create that out of desktop. All right, so yeah, pretty much what I did before, but backwards. So I want to create the gzip archive out of this, or creating this file out of this directory. So let's try that one more time. There we go. That's much better. All right. So notice there was a reduction in size. And now we got a desktop.tar.gz. So if you want to unpack that, you do tar.extract a gzip, and here's the file. There we go. So that will extract it here, but a lot of times you want to extract it somewhere else. Something like that. Oh, that's to extract just the temp out of that. So anyway, I guess the easier way to do that would be to move desktop.tar.gz to TMP. And then let's see, tar extract zip. Here's the file. There we go. And there we go. So we got that home. Once we go in here, you'll see Leo. Go in there. We'll see desktop. So there it is. So it takes that whole entire thing. Hey, and there's my shortcut as well. So it takes that whole thing and archives that up. But the cool thing about gzip is that it will always keep your file path together, and it will always keep your permissions together. So this is another reason why gzip tends to be more popular. So anyway, let me see. Yeah, if you want to do bzip, that whole process, here, let's go back. If you want to do bzip with all of this stuff, let's find my previous command. There it is. Instead of Z, you do J. And then you typically want to have a BZ or BZ2 extension on that. So let's create another one. And same deal, right? So now we have a desktop.tar.bz2. And the process would be the same to extract it. But again, remember, use J to create it, not Z. Z is for gzip, J is for bzip. All right, so there are a few more commands that we got to go through, but we're almost done. We've cleared the halfway point, and there's a few more constructs that you need to understand. Okay, let's clear all that up. Oh my gosh, there we go. Okay, so standard in, standard out, standard error. These are three ideas that basically, I should have made this bigger earlier. There we go. So those are three ideas. So standard input is the stuff that I've been typing into the terminal the entire time. Standard input. Standard output is a command coming out and telling you, all right, I'm done, or okay, or any of that stuff, right? So let's do sudo apt update. So this command is standard input. Hitting enter, number one, that line is standard output. And then all of this is standard output as well. It's just stuff the terminal is telling you. You asked for it, it gave it to you, right? That's the idea. Then there's also standard error. So let's do, right? Surely that's a command. No, it is not. So that command, not found. That is standard error. So when the terminal is giving you information to troubleshoot with, that is standard error. And so these things are represented by 0, 1, and 2. So when we want to redirect text, we can do that. So let's say we're running sudo apt update in the background. And we don't care about anything else except for what if it goes wrong. The only thing that we want to know is what if it goes wrong. At the end of that, you can do something like sudo apt update to, and then let's see, apt errors, something like that. So if you run this command, basically the errors will not be printed on the screen. They will be added to that file. And that makes sense if you want to, if you're running apt update, but you're not there to watch it or something like that, but you want to know if any errors came up during that time. So yeah, this is one way to do that. But that wouldn't have any errors, so we wouldn't get anything in the text file anyway. Okay. So what if you want to do two things, one right after the other, and you don't care whether or not either of them works? I mean, you can do that. Sometimes you do care, but sometimes you don't, right? So let's do LSL documents, semicolon, LSL downloads. Right? Both of them don't have anything in them, so you got total 0, total 0. But it ran both commands. So that is one command, or a one-liner, essentially, to run a bunch of different commands. So you just write it all out, and then runs one, runs the next one, runs the next one, and that semicolon is the delimiter, is the one that says, all right, that command is over with. Now here's the new command, let's run that. And it doesn't matter to you whether or not any of these things works or does not work. That's the deal, right? So if you just want to run a list of commands, this is the way to do it, semicolon. Now, here's the deal. Sometimes you want that first command. You only want the second command to run if the first command succeeded, right? If there was no standard error coming out. If there was standard error coming out, well, then the second command just would not run. So we can actually we just do the same command again and then do and you'll still get the same thing because the first command didn't have an error. I mean, just because it's 0 doesn't mean it's an error. It's literally telling you, hey, nothing in here. So and will then run the next command. So in this case, it's apt get update. So if you do the updates and there's no error, then you will run the upgrade with the Y presupposed, as in, you know, I want it to do yes when it asks me yes. So don't ask me yes, just do yes. And so this command right here will update your entire system. That is one way to just get it all done in one line. You don't have to do apt get update, wait, apt get upgrade, yes, and then wait. So you can just do it all in one line, and it will go through the entire process. So yeah, if you're stepping away for 5 minutes, you just go ahead and update your machine. This is the one-liner to do it with. All right. So there's the opposite of if the first one succeeded, run the second one. It's if the first one didn't succeed, run the second one. So this is apt get update. If for some reason it gives out any kind of error, right? If the first command did not succeed, then send a mail to the root user with the message or with the subject, update broke, right? So I don't know what happened. Update broke. It's time to go in and look at the apt log and see what happened. And it may just be, you know, there was an internet outage or something like that. But, you know, regardless, you get that email, well, locally. You can send it out. You can do a, what do you call those things? A relay. You can do relay and just send it to like your Gmail or something like that. But, yeah, the idea with this is basically you just want to know if anything went wrong while you were gone. And this is a way to do that. And you probably want to put a little more information in that. Like if you run a bunch of commands, like you can say apt update broke or apt get. And then if there were other commands that you were running, you know, like a backup command like tar gz or something like that, you can update your message with tar gz update broke or tar gz backup broke, something like that. Anyway, long story short, that's the idea. If this failed, and that's what that means right there. If that failed, then do that part. Now, the thing is, if it didn't fail, if it succeeded, then this does not get run at all. All right. So T is like cat. So you've seen me do cat with a bunch of things, right? No hub.out. There's a bunch of text there. Cat template. So cat doesn't care what kind of file it is. It'll just dump it out onto the screen. So it's bad if you do this to like zips or GZs or BZs or executable files or something like that, because cat will act on that stuff. There are characters that in the terminal says, hey, this isn't like output or anything like that. This is something I want you to run. And so if you cat a binary, there is a chance that it's gibberish, right? But there's a chance that executable might contain characters that instruct the command line to act on that stuff. And so I've had it where I cat an executable file, and then my prompt just goes away. Like there was like a hidden command in there that that deleted my command prompt or something like that. So it's not likely, but it has happened before. So anyway, so catting things, you have to be very careful with that, which is why less is important. Use less if you're looking at stuff, but cat is just quick, and it's muscle memory for me now, so I tend to do it a lot. Anyway, so T is a really interesting command in that it will do two things at once. It will pour out whatever the output is for a particular file, and then it will create a new file with that output. So one thing that you can do is, so let's see. I don't have Nmap on here. You know what? That's fine. It'll work. Let me just install it. This way I can show you exactly what is in the notes. So Nmap is a network mapping software. It'll basically tell you whether or not there are things on the network. Oops, I don't know what I'm doing here. ifconfig, that's what I wanted. All right, so here's my subnet or my IP address. And I'm just going to scan my entire subnet for MAC addresses that are alive. So let's just see what happens. There we go. So there are a few devices up, 2.2, 2.3, 2.4, and me, of course, 2.15. So let's say that we want to, I want to see that. Like I'm running the command. I do want to see that output, but I also want to create a file out of that output. I want to have both. That's where T comes in. So, oh, you know what? We'll come back to this here in just a minute. So T, and we'll do nmap.output or nmap.out, whatever you want to name it, really. And it'll do all of that. So it looks the same, but you now have this, nmap.out. So pretty nice. And then if you less it, it's got that output. So it basically mirrors it. Puts it out onto your terminal so you can read it immediately, but it also creates a file so you can go back and see what you did. So T is pretty fantastic. This, I know, looks a lot like this, but it's not. 1 is different than 2 of these things. So basically what this is say take the output from this particular command and then give it to this command for it to act on. So what T does is it, again, output stuff to the screen and then output stuff to a file. It does both. All right. So sort is a cool little option that will basically take anything in a particular file and then sort it alphabetically. So let's do sort to nmap.out. So notice what it does. H comes before M, obviously S, right? So where it was starting nmap host, nmap host, nmap host, now it's host, 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 nmap, 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 nmap. And anyway, so the idea with that is that you want it in a particular order. If you want it in numerical order, say you've got a bunch of files that or a bunch of lines that start with a number, then you can do sort-n to do that. Sort numerically. Let's see. And then you can see the different stuff that you got up there. Here's another way that you would want to do that. So the output of the sort -- help, whatever that is, give that to less. So it's like it's a file, but not. And then you can scroll up and down. So that pipe is really useful. Anyway, so yeah, you can see you can ask it to do a bunch of stuff. Numeric sort, you can just sort them randomly if you just want to confuse. You can sort them in reverse order from Z to A. In dictionary order, you can ignore case. So there's a lot that you can do with the sort command. Number line. So nl, nmap.out, and you can see it gives you number lines. This is fantastic for when you get an error message. You don't have number lines in a particular file or something like that, but there's an error message and it says, there's something wrong with line 40. And you're like, but I don't know what line 40 is. I have no idea. So you can do nl, nmap.out, and then just scroll down to line 40. So that is pretty useful. You can do word count. Word count. Yeah. Let me see. Oh, yeah, that's what it is. Okay, so 11 lines, 64 words, and 392 characters. So that is useful to know. And cut. So cut is pretty useful in that you can cut stuff out of a particular file. So later on in the semester, I'm going to have you basically write a script, so something that does multiple things, run a few commands, but only cut out the really important information, and then kind of reform it. So think of like how this works. ifconfig gives you a bunch of IP addressing information, stuff like that. We want to only cut out the IP address, or something like that. So that's where cut really gets useful. But so characters 1 through 25 of the etc fstab file. Yeah. So it'll just show you the first 25 characters of every single line. And cut goes way more in depth than just that. But you can tell it, cut out this many bytes, cut out this character. The delimiter is really cool in that you can tell it, cut out only stuff after you find your first semicolon or before the semicolon or something like that. So just to have a basic idea of how cut works, it will extract stuff and then output whatever you tell it to cut out. Paste is really cool. Yeah, so it will take all of those files and then just dump it out into one thing. So essentially what you want in this, or essentially what you're trying to do, let's just see what happens. So nmap.output, what else was in here? Yeah, no, not the no-hop, that's too big. Oh, template, that'll work. And then you can see, yeah, it's not pretty or anything like that, but if you notice, what's happened is the very first line is unit, the second line starting nmap, and as you follow it along, you see that right here. This is where the files merge. So you have that second line that had starting nmap, blah, 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 and then you have the second line of the template file that has description. This is a template, right? And then that next line, and then you have after that comes from the template. So this is from nmap, this is from the template, right? So think of it like this. You have these files, as I have in here, right? Name.txt, city.txt, address.txt. So let's say that you have a list of names in order. Then you have a list of cities in order and a list of addresses in order. And you want to merge all of those things. How do you do it? The paste command. So you'll have name, then city, then address. The only thing you have to know before you go in there is that, yes, they're all in the same order, right? So, you have John, Bill, and Joe, and, the cities have to match up, right? It has to be John's, Bill's, and Joe's, and then same with address, John's, Bill's, and Joe's. If it's all in that order, then you're great. You just paste them all together, you get all that output, and then you can create a new file out of that, right? You can just have one big, you can call it the database, database.txt or something like that. And it has everybody's names, their city, and their address. Yeah, so join is kind of like paste, but it's when you want files to come together that, say they might have redundant information, right? So like maybe one file has name and city in it, and the other file has names and addresses in it. When you join those two files together, one of those names goes away, right? That information is redundant. So works just like paste, but it makes things a little more readable and gets rid of redundant info. Okay, so head and tail. These are cool little commands in that you want to... I tend to use head and tail a lot when I'm looking at logs, which is why that's what the examples are looking like. So let's go... You know what? Let's go look at a log. Why not? Let's see. Apt. Okay, so let's look at our history. So, you know what? Less history.log. So this is everything that I've done with apt. Oh, it's just today. All the other ones got backed up into this gzip file. So there's really not a whole lot in there. Let me look at term. There we go. That's a little bit better. Okay, so that's a lot of information. Let's say I just want the last couple of things on this log. So instead of doing less, let's do tail term.log. Now by default, what is it, 15, I think, the last 15 lines or last 10 lines let me see. So that would be tail term 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh yeah, so 10. All right. So the last 10 lines of any given file, that's what tail, well, head and tail. So head will give you the first 10, and tail will give you the last 10. So it becomes kind of useful when you're looking at logs and you just want to see what happened most recently. Oh, you know what? Let me go back in there. And let's do that one more time. So tail, you can specify, instead of 10, I want the last 3 lines. And it'll just give me, 1, 2, 3. 3 lines. And you can do that for any particular log. You can look at the security log. Let me see. Oh, syslog is a good one to look at. So let's do, because that one's a lot bigger. And this is, yeah, you just want to see the last couple of things. Tail in 5 syslog. Just want to look at the last couple of things that happened. And it looks like more lines, but you got to count with Feb3, 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 Feb3. Those lines wrap around. So, yeah, I know it looks like more than 5, but it's not. All right, and then head would be the same way. Head in 5, give me the first 5 lines of this particular log. Okay, so sed is basically a converter. It is something that will change one thing into another inside of a text file. So I've got this yes/no example here. So let's nano a file called yes. Oh, wait, you know what? I'm not in the right spot. So let's go home. Nano, let's call it yes. And then what I want to do is yes, 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 yes. Right? Let's save that. Now, let's use this right here. Mine is not named questionnaire.txt, though. It's called yes. So sed s. I want to change anytime the word yes comes up in a file, I want to change that to a no. So S says, here's the thing I want you to change on, to the right of this slash. That's what I want you to change. And the G says to the left of this slash, here's what I want to change it into. So S right here changes to G right here. And then we want to do that in the yes file. And it's just going to output a bunch of no's. So it didn't change anything in the yes file, but when you run that command, it will find and replace. Think of it like as in Word. Find and replace. Every time you see the word yes, you want it to swap to heck yeah or something like that, right? You can do that with sed. All right. So grep. Grep is fantastic. It will show you, it searches stuff for you. And this is pretty fantastic. So what you'll do in this case, let me look at, oh yeah, InMap will be a good one. So let's cat InMap.out. We can see all that stuff. But I just want to know the list. I just want to know the actual IP addresses that showed up. So we just need to find something that's common to every single one of these. So 10.0.2.3, 10.0.2.4, and then 2.15. Those are all up. So what I want to do is I want to whittle that down. I just want the IP addresses. So one thing that we can do is grep the file InMap.out for what? And in this case, I want, you know what? Let's just do up. Oops. Oh, I got it backwards. Keep doing that backwards. InMap.out. So look for this in that. There we go. So you can see all the lines that have InMap in it, because they do not have the word up anywhere in there, they're gone. And that's it. So it does a nice search for you. All right. So E is a pretty cool option if you want to look for one thing or another. So you can do it like this. So you're looking for either bash, CSH, or ZSH in Etsy password. So, I mean, we can actually run this one. This one is likely going to work. Okay, so we're basically saying look for bash, C shell, or Z shell in the Etsy password file. Let's see what it does. Yeah. So only root and Leo have logins. That file is actually quite massive. So if you look at it by itself, it's a bunch of stuff. It's all the users on the entire system, but only a couple of those have logins, actual logins, and that would be root and Leo. And then F, let's say, oh, right. So let's say we had a text file named shells.txt that had, on one line had bash, and then CSH, and then ZSH on each on separate lines. You can tell grep, hey, I want you to do the same thing as this, basically, but they're just in a file. So grep for things in a file, here's that file, and it'll just look for those same things in Etsy password. Okay, so we're on the home stretch, I promise. We've got just a couple more minutes left, so take a sip of that coffee. I will finish mine. It's cold now, but it works just the same. Okay, so kind of in the example before, bash. What is bash? Bash is the born again shell. C shell showed up a lot in Unix, and Z shell is the default Mac terminal. So you can use all of those in Linux. So it's not like you're stuck with one or the other or something like that in Linux anyway. You can use any of those. There's another one called Fish that I think is really, really impressive. It basically just formats the stuff differently, and it remembers what you've done better. I'll show you guys an example of it a little later. I don't want to confuse you. We're focusing on bash. Bash is the thing, but Fish can help when you're learning stuff, so I'll show it to you later. Anyway, so bash stands for the born again shell. It is quite literally the most widely used Linux shell. So if you know one shell and one shell only, it shall be bash. Just simply because, well, I mean, bash is the most popular, so focus on that. As we showed, it's defined here. So here's my user. You can kind of ignore a lot of this, but what I really want you to see is my username. That X says I have a password. We'll talk about security later, so don't worry about that. My user ID, my group ID, my full name, my home folder, and my shell. This is the shell. If you come in here and edit this file and change that to, bin CSH, then, well, that'll be my shell. Every time I open up a terminal or every time I log in, it will just drop me down to C shell instead of bash, or ZSH instead of bash. But anyway, that's the basic idea of it. When you see bin false, means you can't log in. You can't do anything in the terminal. And then user sbin no login. So this says do not log in. Bin false essentially does the same thing. You can log in, but it'll kick you right back out because, well, yep, false. Yeah, here you go. Here's one. False is not a shell. So if you don't have a shell defined in the password file, passwd file, then you just don't log in. This is good for service accounts, right? Everything is a service account that is not a actual person or root. All right. Oh, right. Okay. I meant to do this. What is it? Pi-hole. So if you want to go and do some really interesting stuff, oh, they changed the website. Hopefully it's still super. Yeah, sweet. There it is. Okay. So if you are tired of ads and you are on a phone or something like that, like iPhones, you can't install ad blockers on, not easily anyway. Android, you kind of can depending on your browser, and So if you're in a situation where you want ads to be blocked, or at least most of them, you want them to be blocked, but you don't have the capability to do it on that device or something like that, Pi-hole comes in really handy. It is a DNS server, but it's super duper easy. You really don't have to do too terribly much for it. But oh yeah, here it is. Yeah. Okay. So here's what I wanted. So let's download a script to our directory. So this is not really the part that I want you to pay attention to, but I'll tell you what this does though. Okay. So wget is a web getter. Gets things off the internet. We did this with Discord before. The output, I want the output of whatever I'm getting to go into a file called basic-install.sh, and I'm going to pull it from here. So this website has some pretty cool web magic that when you ask for the site, it actually gives you the script, which is really nifty. Anyway, so let's run that. And then we'll talk about this. So there are a couple of ways that you can run a particular script, and one of them is // The other one is sh. So they have the sh nomenclature here, but you could do it either way. So you can do sudo // Oh, let me double check real quick. All right, so the first thing you need to do is make this executable. So this is not something you have to remember just yet. So we're adding the, oh, you know what? Just add it. Basic install. Now its screen is executable. So you can do sudo / basic install.sh. That will run that script. It will do all of those things, whatever the script tells you to do. But you can also do it this. So basically invoke the shell, or they have bash because they specifically want it to be run with bash. Or you can do sh, which is whatever shell the script mentions. So let's do this. So let's look at the first couple of lines in this. But you can see whatever the environment variable for bash is, use that. So, you know, regardless of how you run this, it's going to be run in bash. They're just being explicit with it. So sudo bash basic install. But you know what? I'm going to take a snapshot. This way I can roll back. I don't want this thing to be a DNS server, but it is pretty interesting to see. So let's see, sudo // There we go. So notice all I did was, oops, no, come back. Yeah. Oh, where is it? Sudo // basic. So it does work. You can do it with bash or you can do it with sh, but // is what I was. This is the whole point. This is the point that I'm trying to make, right? There's a script and you want to run it and you do it like that. If you need root privileges like you do with that particular script because it's going to install packages and do a bunch of other stuff, you'll need sudo in front of it. But otherwise, if it's your script and it's stuff that you have permission to do, then you can just run it without sudo at all. I'm going to try and see if I can cancel this. Oh no! All right. Static IP address, blah, blah, blah. Here we go. Let's just cancel. All right. Okay. So, bash behaves a certain way because the distribution or the user has defined that it needs to run that way. So there are a few different places where you will tell it to run a specific way. You don't know how to do this just yet, or you don't need to know how to do this just yet. But what you need to know is where you would define special behavior. So there is a global place. This is the place that if you want every single user to have the same behavior, you'll put it in here. And basically all this thing does is it defines where exactly or how exactly this looks. So Leo @ Servy : $$ That's defined. and then anything in Etsy profile.d. So let's see, lsl Etsy profile.d. All of those are also run. So notice right here, and it says if there is a directory called profile.d in the Etsy directory, then run, run pretty much every single script. It's just a for loop to do all of these scripts. So again, I don't need you to understand how that works just yet. We'll talk about scripts a little bit more later on, and that'll make more sense. But for right now, don't worry too much about it. Just know that that's what's going on right here. This is how it defines pretty much everything else. So look, PS1 is basically what this is saying is if your user ID is 0, then you get a hash mark. So root's user ID is 0. So when you do that, notice right there, hash mark. And when you exit out of that, you get $sign. So it's basically if your user ID is 0, then you get a hash. Otherwise, it's a $sign. And that's what that is, right? That $sign says I'm a regular user. I am not root. All right. And then you have .bash profile, .bash rc, .profile, .bash. Oh, well, actually, these three. These three are the most important. Now, these are in a particular, in any particular distribution, you can use any of these. And some distributions use some distributions use others. Let's see what we have on Ubuntu. So you have to do A because there's a dot. That is a hidden file. We've got bash. We do not have .bash profile. But we do have bash rc. And we also have .profile. So both of these particular files, if we edit them, they will be run every time you log in, and they will affect your particular profile, however you want that to be. So bash _ profile. Look in CentOS for that one. I've been in Ubuntu this entire time. Look in CentOS for that one, and look in OpenSUSE for that one. You'll see those likely have bash profile. But most everybody has profile as well. All right. So as we've been doing before, you can double up and triple up and quadruple up into these commands, and these are the things that you need to be aware of. So these. We talked about this in the tilde is your own directory, whatever that is. So you can do some cool relative linking. So let's say we're in temp, right? So we can't just say, I want to look at my bash rc or something like that. You can do less my home folder /bash rc, right? So it exists in my home folder. It's right there. And this is a shortcut for home /Leo, or in your case, whatever your username is. So we hit enter on it, and then you can see that file, right? That is an escape character. So $signs are have a special or a special use in Bash. If you type a $sign, it actually won't do the $sign. It won't type it out, or it won't read it normally. A $sign means it's a variable. So if you want, actually, you know what? Let me. Here's an example. So echo path. Path is important. These are all of the directories separated by semicolons. So user local sbin, user local bin, user sbin, user bin, sbin, bin, user games, user local games, and snap bin. Those are all the directories that if I just type in Firefox, it will look in every single one of those directories. And this will work because Firefox lives in user bin or something, but let's double check. User bin, yep. And user bin is in that list. So if I type in Firefox, it'll find Firefox here, and it'll just run Firefox, no matter where I am in the system. So that's nice, but what if I just wanted to actually just type out path? So you have to escape it. And then it will, yeah. So all echo does is echoes whatever you tell it to. Echo, echo. Hello. And it'll say hello. Echo is useful in scripts when you're like giving feedback to the user or something like that. You want it to just dump some text out into the screen. But in that instance, let's say I actually here's a good example. Let me see. Right? Where you don't want it to actually print out path, like all the path stuff, you want it to actually literally say $path. So maybe this is a script where you are asking a user to say, all right, what directories do you want the shell to look through when you're just typing stuff out? That's one way to do it. So, this one, directory separator, we've been using it about 1 billion times today. $, as I mentioned before, it's a variable, so it has a special meaning. You got to be careful with that. So this question mark, as we were using the asterisk before, you can use a question mark to say, instead of saying, I don't care how long or whatever it is, I just want one character. So this could be TMT, TXT, TLT, whatever, but this will likely just find a bunch of text files. Single quotes and double quotes are essentially the same thing, but you can use one inside of the other, or you can, you can really just decide. So backticks, they're really interesting. So take a look at the command date, right? But then we do echo date. It literally says date. Well, I don't want it to literally say date. I want it to actually give me back the output of date, whatever that is. And I put an exclamation point in there. You know what? Let's do... Oh, it's the quote. Oh, that's what it was. I had a quote open right there, and I didn't close it. So, yeah, that's just me being silly. So let's do that. That'll work. So you have today's date and then the actual date. Today's date. Oh, you know what? I don't think the colon is a special character, so let's do that. Yeah. Today's date, Wednesday, February 3rd. And you know what? You can run that over and over and over again, and it'll always be the correct time. So this is good for scripts when you want to just dump the date into a specific spot or something like that. But again, I've got it to where it's human readable, right? Today's date. There it is. All right. So wildcard, we did that before. So this would be ls, any file that starts with DAR, and then I don't care, what comes after it, and then there needs to be a dot, and I don't care what comes after that. So if it matches that at all, give it to me. So the ampersand, we did this before for that no-hup command last time. And this is, whatever it is, push it to the background. But that no-hup allows it to continue running in the background as well. We talked about this one. If the first one succeeds, then do number 2. Pipe, as we were mentioning before, it gives the output to another command. So you just run it in a chain and continue going on. This is, if the first one fails, then do something. We did that one earlier. Multiple commands. Arrange. So you want to list files that have 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, right? So any of those files will match. List all of that. Redirect and then redirect. So let me do one thing. Let's do this. So let's say we want to do a bunch of different things in one go. So let's say I want to... Let's do... All right, let's number line. Oh, I'm in the wrong directory. Let's go home. I want a number line in map. Oh, you know what? Let's not do number line first. Let's do sort in map. So I want that to be in alphabetical order. And then give that output to number line. Let's see what that does. So it doesn't change anything other than, so sort, alphabetically sorts it. Then I'm saying, all right, take that output and then run it through number line. And then number line goes and says, all right, we're number 1, number 2, number 3, number 4, blah, blah, blah. And then to incorporate this last little bit, redirect output to a file. You'll say, all right, and then this is new inmap.out. All right, so no output. All that output was redirected into a new file. So if I do LSL, notice right here, just created it, new inmap.out. And let's do less. Let's take a look at it. And it's got that same stuff. So when you do sort and you do number line, it only acts on it on the output. It doesn't change anything in the file. So if you want to go and actually save the output of that into a new file or into that file, then you have to use the redirector. Let me see. You have to use this redirector right here. So run inmap.out through sort, then run that output through number line, and then take all of that output and put it into a new file called new inmap.out. And then we can do whatever we want to with it at that point. All right. Okay. I promised you we're almost done. This is the last thing I'm going to throw at you today. Set. Set is a command that will change the way that your shell actually works. So one that I'm going to ask you about, hint, hint, is this no clobber down here. So there's some cool things that you want to happen, right? So set O history. So you want to add the O option to history. Let's see. Oh, you know what? Let's do that to less. Let's see if I can find it. Yeah, it's not in there. Oh, there it is. Actually, yeah, it is. So you want to, so O stands for option. So set option no clobber, but the way that I think about it backwards. So plus you would assume that you're turning the option. Well, you know what? Let's just look at it. So let's do set O no clobber. Okay, so clobbering is the idea that clobber is basically overwrite. If you know what, let's do something real quick. So echo hello, and I want that to go into a file called hello. So let's look at that. Let's just do this. Let's look at that file, cat hello, and it says hello. Echo bye into the hello file. And then cat hello, and it says bye. So here's what happened. So I told Echo. Echo basically tells me whatever I tell it to tell me, hello in this case. But instead of giving it to me in the terminal, I want it to redirect to a file called hello. So when I looked at that file, it said hello, right? But I did the same thing. Echo bye. And I redirected it into the hello file. Looked at the hello file and said bye. So this will overwrite anything in the file with whatever you told it or whatever is going to come out. You can, if you add a second one, it'll append instead. Right? So bye, hello. So here's the deal with this though. What I did here, so echo hello into that, and then echo bye into that. Bye clobbered hello. It overwrote hello. So you can turn that behavior off with this. So no clobber, turn it on or off, essentially. So let's see what happens here. Now let's see if it overwrites. And it does. So cat hello. And it only says, so this is the default. And then set -O no clobber. And let's try it again. There. Cannot overwrite. So set -O no clobber prevents you from overwriting things. And this is actually pretty decent, right? I mean, you could typo. It's very easy to do one of these instead of two to append, and this will just save you from doing that. It'll save you from yourself. Because again, you know, there's no backup. Unless you manually stored a backup, there's no backup. All right, so anyhow, that's kind of the idea with that. And this is why I think it's backwards. It's just weird. You just need to remember set -O for no clobber to turn off clobbering. But set the option off to no clobber. But that just reads to me that, like, if we turn off no clobber, then it will clobber things. So it's like two negatives, right? Like there ain't no, it's like no clobber is yeah clobber. But yeah, anyway, one of the cool things that you can do with this though is that you can test it just like I did here. Set +O no clobber. To my mind, that's it seems to me that would turn on no clobber, so I can't clobber things. But again, that's just not how it works. So anyway, so you can test it just like I did right here using the little redirect overwrite thing to test it. And what you want is this. So the question that I'm going to ask you in the quiz this go around is this right here. Cannot overwrite existing file. How do you do that? Like this. So that's the idea. So there are a bunch of things like history. So if you type in the history command, you get all the commands that you've run, like ever, all of them, which is really interesting, and it helps you go back through, your thought process during a specific time or something like that, and it just keeps it forever. I think actually it goes up to like 500 lines or 1,000 lines or something like that. So, once you hit a threshold, it's only going to go so far. You can make that bigger, but the idea is basically, do you want history or not? You can turn off history. So if you want to have like a shadow like session where you come in and history doesn't remember anything that you did, so you can do secret things or whatever. And this is actually one of the things that a virus would do, right? I mean, if it wants to be silent, at least in terms of history, then it would try this option immediately to turn off history. Anyhow, that's it. That's all the stuff. You should be familiar by now. The quiz is all open-ended. Answer the questions. If for any reason those questions do not make sense or you're not quite sure what I'm asking, please hop into WebEx, ask me a question, or email me, send me a Google Hangout, whatever you want. Just ask me. If you are in doubt at all, just ask me. I'll be happy to answer you and help you out with that. The lab, we're just using CentOS and Ubuntu this time. And really, it's just going to be stuff that we've covered. All of the answers to everything in these labs is in the notes. So, yeah. So, I mean, like in this particular one right here, remember that we were doing this with Firefox. And if you want to do it all in one command, remember that we did with the, I think it was the tar command. When you list them, you just put a space in between them. And it'll do all of them. So whatever command tells you where the location of a binary is, and then this one, space, this one, space, this one. That's how you'll do that. And that's really pretty much it. So, create a directory. We did that with Mkdir. Create files. We did that with Touch or Nano or however you want to do it. Archive them with tar and gzip. And you'll do some of the similar stuff here. So this poem, unfortunately, can't copy and paste, so type it out. Type that out into a text editor using Nano or something like that. And then I want you to cut stuff out and to, let me see. Oh, yeah, basically just cut out the first letter of each line and put that into a file and do file redirection and stuff. So that's it. And then demessage, last 12 lines, so use tail there. That's the idea with all of those. So anyway, that's it for the lab. So I will call it quits here.